Good afternoon, students. Today I will discuss the lathe machine. Now, first of all, we will discuss the objectives of lathe machines. In this objectives, we will describe the introduction and history of lathe machines, working principle of lathe machines, classification of lathe, construction and parts of lathe, accessories of lathe, and specification of lathe operations, work holding device, and conclusion. First of all, we will discuss the introduction. The lathe is one of the most important machines, tools in the metalworking industry. A lathe operates on a principle of rotating workpiece and fixed cutting tool. The cutting tool is fed into the workpiece, which rotates about its own axis, causing the workpiece to be formed to be desired shape. The lathe machine is also known as the father of the entire tool family. Now, history. The lathe machine is one of the oldest and the most important machine tools as early as 1569. Wood lathes were in use in France. The lathe machine was adopted to metal cutting in England during the Industrial Revolution. The lathe machine, also called the engine lathe, because the first type of lathe was driven by a steam engine. Now in this figure, we will explain the working principle of lathe machine. Now after that we will describe the working principle of lathe. The lathe machine, the lathe is a machine tool which holds the workpiece between two rigid and strong supports called center or in a chuck or in a face plate which revolves. The cutting tool is held and feed against the revolving work. Cutting tool feed either parallel or at a right angles to the axis or may also at an angle. Now you will see this is the block diagram of lathe machine. Now classification of lathe. In this classification of lathe, first of all we will discuss the speed lathe. In this speed lathe we will divide it into the two categories, the wood cutting lathe and centering lathe, and then again polishing lathe and spinning lathe. And further in engine lathe, the belt driven lathe, individual motor drive lathe, gear hand drive lathe, bench lathe, tool room lathe, capstan and turret lathe, special purpose lathe. In this purpose lathe, the wheel lathe, gap bed lathe, and duplicating lathe. And then last is automatic lathe. In this speed lathe, it is the simplest type of lathe. Due to high speed of spindle, it is called the speed lathe. The speed of the spindle is 1200 to 3600 rpm. It is mainly used for metal spinning, polishing, etc. Now show the figure of engine and or center lathe. In this engine or center lathe, in starting it was driven by the steam engine, so it is called the engine lathe. Not production lathe, found in a school shops, tool rooms and job shops. Primarily for single piece or short runs. Manually operated, the times belt driven lathe, individual motor driven lathe and gear head drive lathe. Now bench lathe. It is a small size engine lathe mounted on bench. The bench model usually of low power used to make the precision machine small and lightweight workpiece. Tool room lathe. Small as engine lathe, It is used for production of small and precision work like tools, gauges, fixtures, and accurate parts in tool room. The different speeds can achieve costly as compared to the same size engine lathe. Now capstan or turret lathe. See the figure of capstan and turret lathe. In this capstan and turret lathe, the modified engine lathe is known as the modified engine lathe. Capstan lathes are used in mass production, used for light duty workpiece. The turret lathe is used in mass production and for heavy duty workpiece. No tailstock. Instead of tailstock, the hexagonal turret is there. No time waste for resetting of tool in this type of lathe. There is no time waste for resetting of tools. Special purpose lathe. Conventional programmable lathe. Operated as standard lathe or programmable lathe to automatically repeat the machining operation. Two axis, so can see exact location of cutting tools and the workpiece in X and Z axis. Computerized numerically controlled lathe, that is CNC lathe, is also known as the CNC lathe. Cutting tool movements controlled by the computer controlled program to perform the sequence operation automatically. Automatic lathe. A lathe in which the workpiece is automatically fed and removed without the use of an operator. It requires the very less attention after the setup has been made and the machine loaded. Now construction of the lathe machine. With the help of this figure we can directly show the construction of lathe. Construction of and the parts of lathe machine. The main parts of the lathe are bed, headstock, tailstock, carriage, feed mechanism, screw cutting mechanism. Bed, made from the cast iron or nickel cast iron alloy. It supports the headstock, tailstock and carriage. Machining and scraping of lathe bed is done with high precision. On top section are machine weighs. The guide and align measure the parts of lathe. Headstock, the clamped on the left hand and of bed. Headstock spindle, hollow cylindrical shaft supported by bearings, provided drive through gears to work holding device. Tailstock, placed at right side of the lathe to support long workpiece. Operations like drilling, taping, reaming can done using the sleeve of tailstock. Carriage, used to move the cutting tools along the lathe bed. Consists of four main parts: saddle, cross, slides, apron and compound rest. Feed mechanism, the three type of feed mechanism: longitudinal, cross and angular. Cross slide, fitted on the saddle, moves cutting tools at right angle to the lathe bed. Top slide, fitted to the top of the cross slide, carries tool post and cutting tools, can rotate to any angle. It is used to turn tapers. Tool post, fitted on the top slides and carries the cutting tool or the cutting tool holder, can adjust the height on some types, can carry four different tool holders used for holding the cutting tools bits, available in the right hand, left hand and straight. Cutting tools can be high speed steel held in the tool holders, can be also ceramics bits held directly in the tool post. Apron mechanism, accessory of lathe: chucks, mandrels and centers. The chucks the 3-jaw chucks, 4-jaw chucks, and collet chucks. Mandrel, plain mandrels, step mandrels, collared mandrels, and screw mandrels. Centers, live centers, dead centers, tipped centers, and ball centers. Specification of lathe. The height of center. Now you will see the specification of lathe. Height of the center, swing diameter over bed, length between the centers, the swing dia over carriage, maximum dia, the length of the bed. The lathe operations. Now we will discuss the lathe operation. The straight turning, taper turning, facing, chamfering, thread cutting, grooving, knurling, undercutting, filing, spinning, forming, polishing, solder turning, spring winding, boring and breeding. Lathe operations. With the help of this figure, we can directly show the lathe operations. Turning. First of all, the turning. To remove the material from the outside diameter of the workpiece to obtain the finished surface. To produce the flat surface at the end of the workpiece or making the face grooves. Boring. To enlarge a hole or cylindrical cavity made by previous process or to produce the circular internal grooves. Drilling. To produce a hole on the workpiece. Reaming. To finishing the drill hole. Threading. To produce external internal threads on the workpiece. Knurling. To produce regularly shaped roughness of the workpiece. Straight turning. Workpiece becomes cylindrical. Motion of the tools is parallel to the workpiece surface. Facing. To make side surface perpendicular via cutting tool, motion of the tool is perpendicular to the workpiece surface. Taper turning. The taper turning is very important operations. The dia of the cylindrical workpiece decreasing or increasing gradually is called as taper turning. The types of taper turning: by using from tool, by setting over tailstock center, by swinging the compound rest, by using the taper turning attachment. Taper turning using form tools. The broad nose from the tool having the straight cutting edge makes half taper angle with the axis of the work. The tall is feed right angle to the work axis. Work is held in chuck or fleece plate. They used to turn the short length of the taper only. Taper turning by setting over a tailstock center. The method is suitable when the work is held at the centers. The workpiece is rotated at an angle to the lathe axis and the tool feet parallel to the lathe axis. The desired conical surface obtained used to turn the small external taper in long workpiece. Taper turning by swing the compound rest. The workpiece is rotated at lathe axis and tool is feed at an angle to the axis of the rotation of the workpiece. The tool is mounted on the compound rest. The tool can be feed at an angle of the compound slide as compound rest is mounted at half taper angle. Threading. It's very important operation. The pointed from the tool is feed linearly across the surface of rotating work part parallel to the axis of rotation at a large feed rate, thus creating threads. Grooving. Tool is fed radially into rotating work at same location to cut off end of parts or provided a groove. Chamfering. Cutting edge cut an angle of the corner of the cylinder, forming a chamfer. Boring. Boring produces the circular internal profiles in hollow workpiece. The boring mills are used for large workpiece. The hole can be bored up to 20 meter if needed. The machine are available with the variety of features: horizontal boring, machine machines, zig borers, knurling. There are so many knurling tools are used as shown in figure. Work holding device, forged or chuck independent chucks used to hold the square, rectangular, regular and irregular shapes of workpiece. Initially, to set the workpiece, it takes the more time. This chuck includes the four independent jaws, the four square holes on circumference of the body. By using key, jaw can be taken in or out independently. Work holding device, the three jaw universal or self-centering chucks. Work holding device, combination chucks, the jaws can be moved in and out simultaneously or independently. The advantage of both the varieties in this chucks. So it is called the combination. The scroll plate is used to move the jaw simultaneously. A screw is used for independent movement. Work holding device, magnetic chucks used to hold the thin workpiece which can't hold by chuck. An electromagnetic or permanent magnetic provide the holding power. In all positions, flux passes through the workpiece and holds. The work holding device, the collet chucks. In production shop, the speedy and accurate centering of workpiece is necessary. Hands to hold the bar, stock collets or chuck is used. Outer portion of the collet is tapered. Now work holding device, drill chucks, used for drilling, reaming, tapering operation. It is held in the sleeves of the tail stalk or spindle of the headstock. It contains the key operated centering jaws for holding the tools. Work holding device. The lathe centers work to be turned between the centers must have the centers hole drilled in each end. Supports during cutting. The most common have solid, most taper shank, 60-degree centers, steels with the carbide tips. Here to adjust and lubricate occasionally. Work holding device. Steady test. The base is made up of cast iron. It is clamped on the lathe bed where the workpiece is to be supported. The three jaw are provided. All jaws can be radially moved with the independent screws. Work holding device. The follower rest. It, it is a it is C types in shapes. The two adjustment jaws to support the workpiece. It is fitted on the rear portion of the carriage by bolt. Hence it moves along with the carriage. They used during the finishing operation or carrying out turning along the entire length of the jaws. Work holding device. Mandrels. There are so many types of mandrels are used. Plain mandrels, collared mandrels, screwed mandrels, step mandrels. The mandrel is used to hold the hollow drilled workpiece. Work holding device. Lathe docks. The lathe docks are the cast metal device used to provide a firm connection between the headstock spindle and the workpiece mounted between the centers. Work holding device. The lathe faceplate. The lathe Faceplate is a round plate that threads to the headstock spindle to the lathe. The faceplate is used for irregularly shaped workpiece that cannot successfully held by chucks. Conclusion: lathe are normally robust in constructions and they will, with good care, the last for many years. It is not unusual for instance to see the good lathes still in uses that are 50 years old. To ensure the good accurate troubles free uses, it is necessary that the correct maintenance routines are regularly carried out and that important surface such as slideways are kept well protected so as to reduce the wear and thus maintain to good accuracy, and the lubricant used are all factors that require our attentions. Thank you.